This video is to explain the conversion factor method and how to use the conversion factor method to convert between units in the U.S. customary system. So in this example, which way shows the correct way to convert 5 ounces to pounds, I want to point out that the correct way to convert always has units that you're canceling across from each other. So we see in the first fraction, that's what we're starting with. We are starting with 5 ounces. So here we are starting with 5 ounces. So for all of the answer choices, we see that we're starting with 5 ounces. Now we're trying to convert 5 ounces to pounds. So we have to decide, what should I multiply by so that I cancel ounces and am left with pounds. So what I'm multiplying by needs to be equal to 1. So you need to know how many ounces there are in a pound. And we know there are 16 ounces in 1 pound. So we know that the first answer choice isn't correct because the numbers aren't with the right words. There are not 16 pounds with 1 ounce. There are not 16 pounds with 1 ounce. So we know those two answer choices are not set up correctly. Then it's left to which one of these answer choices is set up correctly. And again, the key here is making sure that whatever unit you start with or whatever unit you're trying to cancel, you put that on the other side of the fraction line in what you're multiplying by. So it needs to be equal to 1. Are there 16 ounces in 1 pound? Yes. And will ounces cancel here? Yes, because ounces over ounces, ounces divided by ounces, anything divided by itself does equal 1. So ounces on top and ounces on bottom is how you cancel that out. So if you were to then actually figure out how many ounces there are in 1 pound, you would do the multiplication on top. 5 times 1 is 5. And the multiplication on bottom, 1 times 16 is 16. So there are 5/16ths, and what unit would be left? Pounds. Which should make sense that you're dividing 5 by 16 to see how many pounds there are, because you're going from a smaller unit to a larger unit. Here's another example of how to use the conversion factor method, and it's already set up for us. So what I was trying to say is that if I'm starting with days and trying to get to seconds, then days on top cancels when I put days on the bottom. 24 hours in 1 day is correct, and that would cancel out days because days is on the top and the bottom. Then hours on top and hours on bottom cancels, and there are 60 minutes in 1 hour. So this multiplying by this would then get me from days to hours and hours to minutes. Then I need to go from minutes to seconds. Minutes is on top, so minutes is on the bottom. There are 60 seconds in 1 minute. So 1 times 24 times 60 times 60 would give me the number of seconds, which should make sense that all of this is being multiplied on the top because you're going from a larger unit to a smaller unit, which means your answer is going to be a bigger number. So you're multiplying. How would I convert from inches to miles? Well, I don't know the direct correlation between inches and miles, but I do know that there are 12 inches in 1 foot, and there are 5,280 feet in 1 mile. So I can start with inches and first convert to feet. Again, inches is on top, so to cancel inches, I need to put inches on bottom and make sure that this equals 1. There are 12 inches, so the number 12 is with the word inches in 1 foot. So this would be divide by 12 because the 12 is on the bottom, which makes sense because you're getting to a bigger unit when you go from inches to feet. Now, what would I multiply by? If I'm trying to cancel feet and feet's on top, I would need to put feet on the bottom. And then I would put miles on the top. Then I can come over here and use the information that I know or that I was given and say the 5,280 goes with feet and the 1 goes with miles. So it makes sense that we are dividing by 12 and we're dividing by 5,280 to come up with our answer, because inches to miles would be going from a smaller to a larger unit. Okay, there are other ways, and in this first example here, there's a couple different steps to solving this problem. So they're giving you the amount of rubbing alcohol, water, and ammonia that you would need to create 8 bottles of window cleaner. Now it's 6 cups of rubbing alcohol for 8 bottles of cleaner. Then they ask how many quarts of rubbing alcohol would need to be made for a factory that made 1,280 bottles for stores to sell. First, you need to know how many cups. One thing you could do first is figure out, well, how many cups am I going to need to make 1,280 bottles? And we can use equivalent fractions to figure that out, because we're trying to figure out what number of cups would be used for 1,280 bottles. So to solve this using equivalent fractions, I'm going to figure out 8 times what is 1,280, because if I know what I'm multiplying by on the bottom, then I can multiply by the same thing on the top. So if we divide 1,280 by 8, we get 160. And if we multiply 8 times 160, we would see that we got 1,280. Whatever I multiply the bottom by, I need to multiply the top by so that my fractions are equivalent. So 160 times 6 is 960 cups. So that's how many cups I need. I need 960 cups. But we don't want our answer in terms of cups. They made it a little bit challenging here when they said how many quarts. So we now need to take our cups answer and convert it to quarts. Do you know how many quarts, how many cups are in a quart? One way I do this is I use something I call Gallon Man. The big G represents 1 gallon. And then there is 4 quarts in 1 gallon. There are 2 pints in each quart. And there are 2 cups. I should have made that a little bit bigger here. I'll try that again. So 1 gallon. And the key here is 2, but the first thing we start off with is there are 2 half gallons in a gallon. Then we can move to quarts. There are 2 quarts in each half gallon. There are 2 pints in each quart. And then there are 2 cups in each pint. So I can count for each equivalency. So I could figure out how many cups are in a quart by taking one of my quarts and counting how many cups, how many C's I wrote in there. So 1, 2, 3, 4. There are 4 cups. 4 cups is equal to 1 quart. So now I need to multiply by 4 cups and 1 quart. I need to decide, where am I going to put the 4 cups? Where am I going to put the 1 quart? Am I going to put the 4 cups on the top? Or am I going to put the 4 cups on the bottom? Well, it all depends. I'm starting with cups. I want cups to cancel. So if cups is on the top, I need to cancel it by putting cups on the bottom. So 4 cups in 1 quart. So then I would see that I'm doing 960 times 1, 960 over 1 times 4, which is 4. Cups cancels. and 960 divided by 4 would give me an answer in terms of quarts, because quarts is the only unit left there. All right, and one more example. This is quite the challenging problem. There's quite a few steps that go along with this problem as well. You just have to read these a couple times and know exactly what we're comparing. So when you read through this one, you see that Recycling Center A processes aluminum at a rate of 100 pounds per hour. So A is already a unit rate at 100 pounds per hour. We can write that, if we would like, as a unit rate. A is 100 pounds per 1 hour. Now B isn't so simple because they give us a rate of 2 tons per 1 week. So we need to go from weeks to hours. To go from weeks to hours, and they tell us that all day, every day. So weeks, we could go to days, and then from days, we could go to hours. Then we also need to go from tons to pounds, which means you need to know that there are 2,000 pounds in 1 ton. So we're going to have to convert tons to pounds. So if we're going to use this equivalency to convert tons to pounds, we have to cancel tons. Tons started on the top, so we're going to put tons on the bottom, and then 2,000 pounds on top. So tons cancels that way. So now we can multiply, and we see that 2 times 2,000, there are 4,000 pounds in 1 week. But now we need to go from weeks to hours so that we can convert and compare to A. So if we go from weeks to hours, we want to multiply by something that cancels weeks. Well, this time weeks is on the bottom, so if I want to cancel it, it has to go across from it. So weeks is going to be on the top. Sorry about that. So I was saying that weeks would need to be on the top. How many weeks are in, we can go to days. So how many days are in a week? There are 7 days in 1 week. So we can see here that weeks would cancel. But we still aren't in hours. We need to go from days to hours. So if days is on the bottom, I'm going to put days on the top so that days will cancel, and then hours will be on the bottom, which makes sense because hours was left on the bottom over here. How many hours are in a day? There are 24 hours in 1 day. And again, they told us all day, so all 24 days, every day, so all 7 days. So now we have 4,000 pounds on the top in 7 times 24 is 168 hours. And to convert that to a unit rate, you're going to divide, and 4,000 divided by 168, if I round to the tenths, is 23.8 pounds per 1 hour. So again, I divide these to get it into a unit rate, which has a 1 on the bottom. So, which center processes at a faster rate? Is it faster to have 100 pounds in 1 hour, or 23 pounds in 1 hour, or 24 if we round it to the nearest whole number? 100 pounds every hour is faster than 24 pounds every hour. So that's some examples on using the conversion method for converting customary units. Thank you.